So here we have a review problem asking us to find the equation of this absolute value function. Now, there's a couple ways to do this. I'm going to show you, I'll talk about both, but I'll show you the way that works best for us in the future as well, because this method that I'm going to talk about works for any function, not just absolute value functions. But when I am doing this, basically what I want to solve for here is I want to figure out what my h and k value is first. So the vertex helps me find that, and I can kind of set up this equation as f of x equals, I probably am going to have some sort of stretch or compression value, I don't know yet, and then I'm going to have my absolute value of x minus 3, because I'm moving 3 units to the right, and then plus 1, because I'm moving 1 unit up. And to find the a value, the quick way with absolute value functions is to look at the slope of each of these lines. I'm not going to do that just because there's a better way for the future, which I'm going to kind of walk you through, and that is going to be using a second point. So let's say this point right here, which is 6 comma 5. If I have a second point, I can plug that into the equation and solve for a. So I have my y value of 5. I'm going to search for a. I'm going to plug in 6 for x, and then I'm going to solve this. So first I figure out what's inside the absolute value, which is 6 minus 3, which is 3. And then the absolute value of 3 is just 3. I subtract 1, so I get 4 equals 3a. So I subtracted 1 from both sides. And then divide both sides by 3. So a is equal to 4/3. So again, what you can kind of notice here is that if you were to check the slope, 1, 2, 3, 4 units up, 1, 2, 3 units to the right, you'd still get the same answer, but this process here that I did in blue is going to be really important as time goes on. So my final answer here, f of x equals 4/3 x minus 3 plus 1.